Hello, Primary 7 candidates. Welcome to today's Explainer. It's a special interactive math lesson made just for you as you get ready for your PLE. Take a deep breath. I am so excited to be your guide today. We're going to look at a topic that is absolutely guaranteed to pop up on your papers: sets. And more specifically, we're going to dive right in and unlock the secret of subsets together, step by step. Let's do this.
Okay, let's jump straight in. I want you to imagine a really big set of items. It could be, a set of your absolute favorite fruits, or maybe a massive set of whole numbers. Have you ever wondered how to quickly count all the smaller groups, the subsets, hiding inside it without missing a single one? Just guess for a second how hard it would be to find every single combination hidden inside a really large set. If you're sitting there thinking, wow, that would be nearly impossible to do quickly in a high-pressure exam, well, you're asking exactly the right questions.
And hey, speaking of exams, the Uganda National Examinations Board, UNEB, reported that over 817,800 candidates sat for the 2025 PLE. Let that sink in. That is a massive number of students sharing the same exam room, looking at the exact same math questions as you. So to stand out and succeed, you got to be sharp. You need to know your shortcuts. Mastering these specific math concepts, like the ones we're covering right now, is exactly what's going to give you that winning edge when the invigilator says, "You may begin."
So let's make absolutely sure we're all starting on the same page. What actually is a subset? Well, it's simply a set formed by picking some, all, or even none of the elements from a given finite set. Think of it kind of like a family living in a house. If the main set is the whole family, a subset could be just the parents, or just the kids. It could even be the whole family standing together, or, and this is a super important trick to remember, an empty room with nobody inside at all. Now, here's what's really interesting about what our curriculum tells us to do. The National Curriculum Development Center, or NCDC, has a very specific rule for us. They explicitly say we must not just memorize formulas blindly. Nope. As P7 candidates, we need to act like real mathematicians. We have to derive the formula ourselves so we actually understand where the mathematical magic comes from. So I've got a question for you. How do we find these subsets practically? If we aren't just going to jump straight to memorizing some math trick, how can we figure out the exact number of subsets using just our hands, a piece of paper, and our brilliant brains? Well, let's figure it out together right now.
Let's try listing them manually for a very small set just to see how it works. Step 1. Always start by listing the empty set. Remember, the empty set is a subset of every single set out there. Step 2. List out all the possible sets that just have one single element. Then you build up to groups of 2 and so on. And finally, step 3. List the full set itself, because technically, every set is a subset of itself. See, we just built them practically, right from the ground up.
Okay, so here's the catch. This listing method, it's fantastic for very small sets. But what if the set is huge? What if a set has 5, 6, or even 10 elements? Honestly, if you sit in your PLE trying to list out every single subset manually, it's going to take way too much time. It's exhausting, the clock is ticking, and you could so easily lose track and miss one tiny subset. And that, unfortunately, costs you your marks.
Which leads us to a really brilliant question. Instead of listing them one by one every single time, is there a secret pattern hidden in the numbers? I want you to look really closely as we add more elements to our set. Put on your detective hat for a second. Keep your eyes wide open for how the total number of subsets changes as the set grows.
Just look at the pattern unfolding here. If we have one element, we practically list 2 subsets. If we add a second element, we list 4 subsets. If we have 3 elements, we list 8 subsets. Do you see the connection in the numbers? 2 subsets is just the number 2. 4 subsets is 2 times 2. 8 subsets is 2 times 2 times 2. 2, 4, 8. What exactly is happening here?
Yes, the pattern is always multiplying by 2. Every single time we add one more element to our main set, the total number of subsets literally doubles. See? You just figured out the math secret all on your own. You didn't just memorize a boring textbook rule, you proved it by spotting the pattern like a true, sharp mathematician.
Because we're just multiplying the number 2 by itself over and over, we can write this out as a simple, magical mathematical formula. 2 to the power of n. In this formula, the little n simply represents the number of elements in your finite set. You literally just count the elements, put that number in place of n, and do the multiplication. This is your perfect, powerful shortcut.
But wait,
Examiners love to test if you're truly paying attention to the fine details. Sometimes they won't ask for all the subsets. They're going to ask for a proper subset. Do you know the difference between a normal, ordinary subset and a proper subset? Let's introduce this tiny twist right now so they can never catch you off guard in the exam room.
Here is the twist. A proper subset includes all the subsets of a given set except for one very specific group, the set itself. Remember when we listed our subsets manually and our very last step was to list the full original set? Well, that one is actually called the improper subset. To find only the proper ones, we just have to remove that single improper group from our final total. It's that simple.
So let's compare these two ideas side by side. If the exam asks for all subsets, you use your main formula, 2 to the power of n. But if the exam asks for proper subsets, you use the formula 2 to the power of n minus 1. That minus 1 represents taking away the original set itself. If you just remember this tiny difference, subtracting that one improper set, you are never going to get tricked on exam day.
Okay, I think you've got all the tools you need in your mathematical toolkit. Are you ready for a PLE practice scenario? It's time to step up and apply the formula we just proved. Grab an imaginary pen and paper, clear your mind, and let's tackle a real exam-style question together. You've got this.
Here's your question. A finite set has 4 elements. How many proper subsets does it have? Read carefully. It says 4 elements, and it specifically asks for proper subsets. Think about which formula you need to pull from your memory right now. Let's talk through the math step by step to get to the finish line. Step 1. Identify your n. The number of elements is 4, so n equals 4. Step 2. Because it asked for proper subsets, we write down our special formula, 2 to the power of n minus 1. Step 3. Let's calculate. 2 to the power of 4 means 2 times 2 times 2 times 2. That gives us 16. Then we do our final step, subtract 1. 16 minus 1. And we get 15. There are exactly 15 proper subsets. If you got 15, give yourself a massive round of applause. Seriously, you correctly identified the number of elements, chose the correct formula, did the math perfectly, and remembered the trick to subtract 1. You are absolutely ready to handle subsets.
Before we wrap up today's explainer, I want to leave you with a fascinating question drawn right from your syllabus. Today, we used our formula for finite sets, sets that have a clear end, sets we can easily count. But could you ever list or count the subsets of an infinite set? A set that just goes on forever and ever, like the stars in the sky? Think about that to keep your mathematical curiosity sparked. Keep practicing, believe in yourselves, and I wish you the absolute best in your PLE exams. You're going to do great.